The electromagnetic effect question. Explain why the reading on the ammeter is zero when the wire is not moving. So when this wire is not moving, why this ammeter shows a zero? Because there is no change in the magnetic field or no electromagnetic induction or no magnetic field lines cut, that you can also mention, or no change in magnetic flux. You can use the term magnetic field. You can also use the term magnetic flux, and you can also use the term magnetic field line cuts. So no change in magnetic field, no change in magnetic flux, or no, it does not cut the magnetic field line. That's why there's no induced EMF or a current. The wire XY is moved and there's a deflection on the ammeter that indicates there is a current from X to Y. The table 7.1, tick one box to indicate the direction of the movement of X and Y and explain your answer. So first thing in the question they mention, the current is from X to Y. Whenever electromagnetic induction is there, which hand we use, right or left? Electromagnetic induction, which hand we do? Right hand. Because of electromagnetic induction, we always use the right hand. Left hand is, if we know the current and we want to find the force, then we use a left hand. But here, the current produced due to change in magnetic field, so we'll use a right hand. So if you use a right hand rule, your index finger or your first finger represent the magnetic field. So where the magnetic field is pointing, so north to south means towards the right hand side. The second finger represent the direction of the current. First finger representing the magnetic field. The second finger represents the direction of a current. So in this case, the direction of a current is from X to Y, means in this direction. So where your thumb is pointing, your index finger is pointing. When you apply the rule, your index finger is pointing towards south, which is towards the right hand side. Your thumb will point, your second finger represent direction of the current, which is from X to Y, where your thumb is pointing. Which direction the thumb is pointing? Thumb is pointing upward. So this will experience an upward, or the wire will move upward. The force on the wire is upward. So the wire XY is moved and the deflection is there from, the current is there, conventional current from X to Y. So we have on the table, we have to tick one box which indicates the direction of movement of XY. So which direction XY has moved? To the top of the page. No, we won't apply a left hand rule if there was a current and we were finding force. Here we want to find the induced EMF. So when we want to find the induced, like here we want to find the direction in which the wire, the motion of the wire according to the induced EMF, we have to use a right hand rule. If we have the current, like if there was a supply, and then it's placed in a magnetic field, then we'll use a left hand rule. But in this case, we don't have any supply. Whenever the wire moves, there is a change in a magnetic field, and this change in magnetic field will induce EMF. That's why we have to use the right hand rule. Then explanation. So first point you will mention, the wire is moving perpendicular to magnetic field, and we'll use the right hand rule to find the motion of the wire. All should be 90-degree or perpendicular to each other. So two rules are different. I'll summarize after doing the last part of this question. State what is observed on ammeter when XY is moved in opposite direction. So if it move in opposite direction, what will happen? The current was in X to Y. So the direction of a current will change. So it will become opposite. So it will be opposite direction in the same direction but a greater speed. So what will happen? It will have a greater current or a large deflection.